As Cassini settled into orbit around Saturn in mid-2004, one of the most historic chapters of the mission was about to unfold. Nestled within the spacecraft was the Huygens probe, built by the European Space Agency. Its target? Titan, Saturn's largest moon, and one of the most Earth-like bodies in the entire solar system. Titan had long fascinated scientists. Shrouded in a dense, nitrogen-rich atmosphere with a surface pressure higher than Earth's, it was mysterious, hazy, and cold, its surface hidden beneath thick clouds of orange smog. But it wasn't just the atmosphere that drew attention. Titan's surface features, lakes, rivers, and possibly rain, suggested active weather systems, though not of water, but liquid methane and ethane. On December 25, 2004, Cassini released the Huygens probe. For 3 weeks, the lander coasted silently toward Titan. And on January 14, 2005, it began its dramatic descent. For over 2 hours, Huygens plunged through Titan's thick atmosphere, deploying a series of parachutes to slow its fall. Instruments aboard measured wind speeds, temperatures, and chemical compositions. It was the first time any spacecraft had attempted such a landing in the outer solar system. The stakes were astronomical. As Huygens descended, its cameras pierced the haze and revealed a world eerily reminiscent of Earth. Dark river valleys, icy highlands, and coastlines that looked carved by liquid flow. But this wasn't water shaping the surface. It was methane, flowing like rivers across a frozen desert. When Huygens finally landed, it bounced softly on what appeared to be a damp, sandy plain. The data confirmed what many had hoped. Titan's surface was solid, complex, and geologically active. It wasn't a lifeless rock, it was a dynamic world, sculpted by alien weather and strange chemistry. For 72 minutes, Huygens transmitted images and readings from the surface, giving humanity its first view from the ground on a moon beyond the asteroid belt. The photos showed rounded pebbles, possibly made of ice, strewn across the landing site. Evidence of erosion, movement, and perhaps even seasonal cycles. What Huygens accomplished was nothing short of revolutionary. It proved that the conditions for complex planetary processes weren't exclusive to Earth. Here, on a frigid moon nearly 1.4 billion kilometers from the Sun, rivers flowed, clouds formed, and rain fell. Titan became the first world in the outer solar system where humanity had stood, even if only through our robotic envoy. Cassini, orbiting high above, served as the communication link, relaying Huygens's data back to Earth. The partnership between the two spacecraft marked a milestone in interplanetary exploration and international cooperation. It was a moment when science transcended borders and united efforts from across the globe. The success of Huygens inspired new dreams. Could Titan harbor microbial life in its subsurface oceans? Could future missions land floating probes on its methane seas? These questions have since driven mission proposals like Dragonfly, a rotorcraft lander set to launch in the 2030s. But none of it would have been possible without Cassini and Huygens paving the way. The images from Titan's surface, of dim sunlight filtering through a thick alien sky, remind us that the universe is not just vast, but richly diverse. Every world has a story, and Titan's is just beginning to be told. Up next on Infinity Beyond, we'll shift our gaze to Saturn's other mysterious moon, Enceladus, and uncover the astonishing discovery that changed the search for extraterrestrial life forever.